Welcome to Alaska Earthquake Science Facts. I'm Carl Tate. The EarthScope seismic array began on the US West Coast in 2005, moved east, and then jumped to Alaska in 2014. By Alaska, the station design had evolved to a multi-instrument system capable of observing earthquakes, volcanic eruptions, landslides, storm systems, sea ice formation, meteors, ground thaw, and more. Here's a map showing the station coverage of the EarthScope seismic array. And as of end of 2017, these stations in the northern and western portions of Alaska filled in what were vast regions that had never seen seismometers before. And so in large parts of this map, we have new geophysical data acquisition and scientific discoveries to come. By comparison, in the lower 48, the standard equipment used to install these stations were driving trucks, these vaults, ditch diggers, buried in the ground, as you might expect. However, in Alaska, it was helicopters, drills, huts, post-hole seismometers. What's shown here is a sketch of the station design in Alaska. This fiberglass hut contains the power systems, digitization equipment, protect things from the elements. Solar panels shown here, satellite antenna to broadcast data in real time to data centers for operational and scientific analyses, GPS for timing, a weather station shown here, soil temperature profiler. In a place like Alaska, we're very interested in the thermal conditions of the ground for monitoring permafrost thaw, for example. Here we have infrasound sensor, barometer, microbarograph. The connection here from the power system is to a borehole 8 feet deep with the seismometer directly placed at the bottom. So this is the station design in Alaska. You show in a Northern Brooks Range site showing a setup here. And this station is capable of recording ground motion, infrasound, such as from volcanic eruptions, the weather, soil temperature profile. So a lot of information is captured by this equipment. And here's an example of what it takes to create this hole in the ground to place the seismometer. You have to imagine this drill is being transported by a helicopter near the flanks of Spur Volcano in south central Alaska. And it's a reminder of the effort and extent we go to create a station that's well coupled to the earth. By putting the station down in bedrock in the ground, the sensor can more faithfully record the ground motion than if it were just sitting at the surface or not as well connected to the earth. So this effort and this drill allows the seismometer to essentially record more of the kinds of information that we want to analyze and study. From that same site, here's springtime in Alaska, and you can see May 13th, the amount of snow coming down, kind of a reminder of the challenges faced in these environments. In this case, a lot of snow needed to be dug out. You can see the helicopter landed right here on top of the snowpack and needing to get some sunlight to probably get this fired up again if it had gone down at all. A couple other photos to convey this kind of effort. Keep in mind, in these cases, Western Alaska, this is British Columbia, and you can see these rocky, remote regions, not even trees in these areas, and the people on the ground for scale with the helicopter slinging in equipment. The drill was a key piece of equipment needed to put the hole in these rocky conditions for the seismometer. It's not something you could do on a typical seismic experiment with temporary deployment where you might dig a hole in the ground to put a vault. In this case, you need a real professional drill. Here's a site from Northern Brooks Range. You can see there's tundra, Northern Alaska. There's no trees in sight. And as I put in this photo, Not a sign of life anywhere, right? Right? And here's just a horror of a photograph of mosquitoes. I think it's the worst I've ever seen in a photograph, and the kind of conditions you may um, not think about when you're analyzing seismic data from the comfort of your computer. But this is the kind of effort that went in and goes in to getting seismic data throughout Alaska. The station huts are sturdy and secure for harsh Alaska weather and curious critters, but as it says here, some bears don't read the do not disturb sign. So there are other kinds of hazards, even with these tough designs. So this photo in just out of the archive as a reminder that, science is fun. And despite the obvious drizzly conditions in this case, these five were inspired to take a group photo, and we should share that kind of fun with you. And here's a kind of shot, Mount Upton, Yukon Territory, Wrangell St. Elias Mountains, uh, featured as other science facts of how they got to be here. But it's just a remarkable setting for this 028M setting of sitting out there all by itself and recording all the activity. Takeaway topics. The EarthScope seismic array was completed in 2017 and helped fully cover Alaska with seismic stations. Installation in roadless Alaska required new logistics compared with installations in the lower 48. Boreholes provide improved data quality, allowing for the analysis of subtler signals, and in some cases, new geophysical signals. The legacy of the project is a multi-sensor station for ground motion, weather, infrasound, and soil temperature, and it can support more sensors. So those are just an example of what's out there now. Thank you for watching. Please stick around for supplemental material.